This is section 4.4, and we are going to start working with polynomials. All right. Okay, so just some definitions, some terminology to make sure that you understand what it is I'm saying when I use these terms. I guess I should say words instead of terms. A term in math means something that is separated from other terms by a plus or a minus. So if this were subtract, this would be a term, this would be a term, this is a term, and this is a term. So this polynomial has 4 terms. The leading term, or the first term, is this one, 4x cubed. This number right here is called the coefficient, or the numerical coefficient. 6 is the coefficient for the x squared term. 5 is the coefficient for the x term, and 8, we can call it a constant, or technically it is the coefficient of x to the 0. Not something you really need to know. We usually just call it the constant. Okay, so name the coefficient of each term in the expression. So first thing we have to do is figure out how many terms there are. And when I say how many terms, that is in the simplified form. So simplify it first. So I have this term and I have this term. So I've got 2 terms. And the coefficient for the x cubed term is 2. And the coefficient for the x term is -1. All right, so 2 terms. 2 is what we call the leading coefficient, and -1 is the coefficient for the x term. Speaking of combining like terms, again, something that you would have experience with, but I find that as soon as we start talking about exponents in any math class, then students suddenly cannot remember how to combine like terms. So be really, really careful that when you combine like terms, they actually have to be like, and you only change the coefficients. So for example, if I have 19m to the 5th and 14m to the 5th, we would call those like terms. But if I had 19m to the 5th and 14m to the 3rd, these are not like terms. You cannot add or subtract them. You can't combine them. We could multiply them. That's not what we're trying to do here. We cannot add them or subtract them. Like terms, some more examples of like terms. If I have 7x, 7y, those are not like terms. -4xy squared, 5x squared y, not like terms. So you have to have the exact same variable with the exact same exponent. Okay, so my r squared and my 5r squared, those are like terms. They have the same variable, same exponent. When we add them together, we're going to add the coefficients and the variable stays the same. So this right here is going to give me 6r squared. I cannot combine the 3r with my r squared. That is as simple as we can make that expression. This one, these are not like terms. We cannot combine these. So this is this, we're done. We can't combine them. Vocabulary. So I want to get this a little bit more out of the way. Let's suppose, and come on. It happens every time. All right. So let's suppose we have this term right here, 3x to the 4th. We would call the degree of this term 4. The way we do that is we look at the exponent on the variable. So whatever the exponent is on the variable, that would be the degree of that particular term. For 5x, 5x is really 5x to the first power, and so the exponent is 1, which makes the degree 1. Be careful with this one. This is our constant. Remember I said at the beginning that this is the same as -7 times x to the 0 power. Don't forget x to the 0 power is really just 1, so -7 times 1. That's why that works. So the degree would be 0. This one is a little bit tricky. Notice I have x squared y, or y to the first power. What we're really doing is we're not going to take the exponent on this variable. We're not going to take the exponent on that variable. What we're really concerned with is how many times is any variable being multiplied together. So in this case, I have 1, 2, 3 exponents, or three variables being multiplied together. So my degree would be 3 for this polynomial. Keep saying that wrong. It'd be degree 3 for this term. Okay, so the way we figure out the degree of the polynomial is slightly different. The way we figure out the degree of the polynomial is we look at the degree of each term. So this would be 4, this would be 2, this would be 0, and we take the highest one. So between degree 0, degree 2, and degree 4, 4 is the biggest. So we would say the degree of the polynomial is 4. Degree 1, degree 0, the biggest is 1, the polynomial has degree 1. 3, 2, 2, biggest one is 3, the polynomial has degree 3. We've got a 5 and we've got a 6, degree 6. Take the highest degree term, and that's the degree of the polynomial. Okay, some more vocabulary, lots of vocabulary in this section. A monomial, okay, is a polynomial. It has one term. You guys know that this prefix mono means one. There are lots of things that have this prefix. For example, the monorail that we have, that means it has one rail. These are examples of polynomials with exactly one term. As opposed to a polynomial that has two terms, we call that a binomial. Bi means two. For example, a bicycle has two wheels. A binomial has two terms. Two terms, two terms, two terms. So each of these would be examples of binomials. And the last one that has a special name is something with three terms. Tri means three, like a triangle or a tricycle. Triangle has three angles, three sides, three angles. This literally means three angles, in case you were wondering. And examples, we've got three terms, and three terms. One thing that I tend to ask my students is what would we call a polynomial that had four terms? Or students ask me that sometimes too. What would we call a polynomial that has four terms? Well, you actually just call it a polynomial. We don't have a special name for a polynomial with four terms. We've got one term, two terms, three terms, but once we get to four terms, we don't have a special name for it. We just call it the generic polynomial. All right, simplify, give the degree of the polynomial, and tell whether the simplified polynomial is a monomial, binomial, trinomial, or none of those. All right, so we're going to combine like terms. In this one, it doesn't have any terms to combine. So this has degree. So we're going to look at the degree. I'm going to clear this up. So we have this term has degree 3, and this term has degree 0. Degree 3 and degree 0. So the highest of those would tell us that the polynomial has degree equal to 3. And then we're going to count the number of terms. So we've got 1, 2 terms. 2 terms tells us we have a binomial. Wow. I think I must be getting tired. Sorry about that. So degree is 3, and it is a binomial. We can combine all of these, actually. So 12 subtract 14 gives me a -2, plus a 3 gives me 1. So simplified, we get just x. Okay, so we simplified it. This is to the first power, so the degree is equal to 1. And there is 1 term, so it would be a monomial. We can combine all of these as well. 6 subtract 7 gives me a -1, plus 3 gives me 2xy. And the degree, I have 2 variables being multiplied, so my degree is equal to 2. And I have 1 term, so it's a monomial. Evaluate, when we say evaluate, what we mean is we take the number that they give us and plug it in and then simplify. So we have 2, and I'm going to always plug in with parentheses. -1 to the third power, 8 times -1 minus 6. Okay, we have to simplify it down to one single number. So -1, remember we do exponents first, right? PEMDAS. Parentheses, there are no grouping parentheses. Then we do exponents. So -1 times -1 times -1 is -1. Multiplication and division. Multiplication, division, remember those are actually the same step. So we do multiplication left to right, multiplication and division left to right. So we're going to get -2 minus 8 minus 6, and now we're going to do addition and subtraction. Again, same step, left to right, which gives me a -16. All right, I don't want this video to end up being too long, so I am going to pause here and start another video to finish up.